Lecture 9, Clustering, Part 2. After having an introduction to clustering and having the distance measures and normalization of our data, now we are ready to apply a clustering method. So here we first consider the hierarchical clustering approach or method. So here we have two methods for hierarchical clustering, which are agglomerative and divisive. Okay, so first let's consider the agglomerative hierarchical clustering. In this method, we start with each observation in its own cluster. That means if we have n observations, then we have n clusters at the beginning, right? Each data point is a cluster here. Then we calculate the distance between each pair of clusters, or at the beginning the points. Then we will find the two closest clusters, and then we will combine those two to be in one cluster. That means in step 2 we will have n minus 1 clusters, right? Then we repeat this step until all data points or observations are in a single cluster. That means we will have just one cluster at the end. Okay, so this is called agglomerative hierarchical clustering. In divisive, it's in the opposite direction of the agglomerative. So here we start with one cluster at the beginning, including all observations or data points, and then iteratively we split the cluster into two pieces. Okay, so this is how this works. In our course and in lecture 9, we're not going to cover the details of divisive method, so we will have just the agglomerative hierarchical clustering in the category of hierarchical clustering methods. Okay, let's have an example here. Here we have five data points. As you see here, we have 5 data points, and each has a different color. That means each data point here is a cluster. So at the beginning, we have 5 clusters. Then we'll see which two clusters are closest among the others, and then we will combine those two. Okay. So I see here, these two here are more closer than other clusters, so we will combine these two to be in same cluster. Then so here we have those two are in green. That means now we have one cluster of green, and then 3 more clusters. Okay, in the next step we will see this data point or cluster is closer to this cluster, so we will combine these two clusters as well to have one cluster for these two clusters, so that now we have 3 green data points in one cluster, and we have 2 more. Again, these two are closer, then we combine those two. Now we have 2 red and 3 greens. And now at the end, we combine these two clusters, and at the end we have a single cluster, right? So we are done here. At the end, after completing the process of clustering, we can display the clustering process by a dendrogram here. So to do so, first we list the data points at the bottom. As you see here, we have 5 data points in different colors. So, and then we can see how clustering has been applied here. For example, here, as you see, these 2 points, these 2 data points are clustered first, right? And then this cluster with that, and then these 2 clusters, and then at the end, the 2 clusters at the end. Okay, so and the height of the lines here is about the distance between the 2 data points or the 2 clusters. After having the dendrogram, we can apply an analysis to see what would be the desired number of clusters. So for example, at the beginning we have n clusters, right? And at the end we have just one cluster. So between 1 up to n, we will see what will be the desired level. I mean, what will be the desired number of clusters, okay? So as we saw in the hierarchical clustering method, we are not going to obtain a desired number of clusters first. We start with n clusters, I mean the number of observations, and at the end we will end up with one cluster. And then by having a dendrogram, we can see what would be the desired number of clusters at the end by having an analysis on the dendrogram. So here, in order to apply that analysis, we can imagine a horizontal line cutting across the dendrogram, okay? So the number of vertical lines crossed by the horizontal line will show the number of clusters to select. And a criteria here to obtain a desired number of clusters would be this. A good choice is if the horizontal line has a lot of wiggle room without running into a horizontal line of dendrogram. Okay, I'll show this on our example. But at the end, by having this analysis at the end, the decision maker should see what number of clusters would make more sense in that particular application. Okay. So here in our example, for example, consider this this horizontal line, and as you see here, it's cutting two vertical lines. That means by this choice, we will have two clusters. And as you see here, we have a lot of wiggle room, right? Right? In this horizontal line, we have 1, 2, and 3. 3 cross, so we'll have 3 clusters. And again, a reasonable wiggle room we do have here. Or maybe this one, right? As you see here, 1, 2, 3, and 4 crosses. So that means we'll have 4 clusters here. And again, acceptable level of wiggle room, right, between these two horizontal lines here, right? And also for this one, we have 6 clusters and so on. So yeah, by this approach, we can see how many clusters is desirable for our application. And beside this, we should see which choice makes more sense. Okay.